This is my antenna rotator, minus the antenna for now. Over the past weeks we built the controller, the rotator assemblies and the tripod. All of that was covered in recent videos. Last week I finally mounted everything together. Did you see what just happened? The rotator was moving clockwise and suddenly it took a full turn counterclockwise before continuing on its way. That's a minute of radio link lost in the middle of the precious 10-minute communication window. So what is going on? I'm using the Gpredict software tool to follow satellite passes. Gpredict talks to the rotator through a translator called Rotctld. Gpredict issues azimuth strictly between 0 and 360 degrees. Now imagine a track that goes from 50 degrees down to minus 70 degrees, which Gpredict represents as 290 degrees. Everything is fine until we cross the 0-360 boundary line. The sequence goes like this: 50 degrees, 30 degrees, 10 degrees, and then Gpredict jumps to 350 degrees. Rotctld does not question it. It rotates the long way around from 10 degrees to 350 degrees as instructed. Once at 350 degrees, the commands continue with 330 degrees, 310 degrees, 290 degrees. All perfectly valid, but the damage is done. We got an unnecessary full rotation and lost the radio link during this time. Gpredict's solution is to flip the antenna over the top and track the complementary path. I tested that. It works, but I don't want the antenna going over the top. It is hard on the antenna and the wiring. So I built a different solution, a small Python interceptor. It watches Gpredict's commands and decides whether adding or subtracting 360 degrees gives a smaller step. For example, Gpredict says, go from 50 to 290 degrees. That's a 240 degree step. The script checks for alternatives. 290 plus 360 is 650, which results in a worse step of 600 degrees. 290 minus 360 is minus 70, which has a step of only minus 120 degrees. So the script rewrites the command to minus 70 degrees. Rotctld and the rotator don't care, they just move as instructed. Going the other way from 290 to 50 works the same. In this case, the script rewrites the command to 410. This interceptor script gives me a clean track with no surprise rotations. The trade-off is that the rotator's effective range becomes minus 180 to 540 degrees, which can wrap cables around the tripod up to 1.5 turns. But Gpredict also supports a minus 180 to 180 azimuth mode. If we use this configuration and use the script in the loop, the rotator range becomes symmetric, minus 360 to 360, and the cable wraparound is limited to only one turn. This morning's ISS pass started at minus 160 degrees and ended around 50 degrees. It crossed the boundary at minus 180, 180. Without the script, we would have gotten another full rotation. With the script, the track was smooth. 10 minutes from rise to set. No drama. Now that mechanics and software are behaving, next up is RF, antenna, LNA filter and SDR. So stay tuned. The next episode is where we finally receive satellite signals. Subscribe and you will not miss it. Thanks for watching. See you next week.